So assuming you read the problem, you should see. For part A, we are looking for the strength, the electric field, 1 millimeter above the center of top of the copper plate. So here's the copper plate, and the blue dot is what we are looking for. And first, remember that the plate is negatively charged. So now we have Gauss's law, which is EA times sigma divided. No, EA is equal to sigma divided by E epsilon naught. E is the electric field, A is the surface area, sigma is the electric charge density, or the charge density of a surface, and epsilon naught is just a constant, 8.85 times 10 to the 12 power of whatever unit it's in. So we need to replace the sigma with in terms of Q and A. So the enclosed charge is equal to sigma times A. Sigma again is the surface charge density, A is the surface area. So divide both. So in the right of the semicolon, divide both sides by the surface area, and then you just get that the linear, the surface charge density is the enclosed charge divided by the surface area of a Gaussian surface. So yeah, now just rearrange to this equation. If you plug in Q over A for sigma, and now it's EA is equal to Q divided by epsilon naught over A. And I'm only going to use mean once because it's only 40 once. So yeah. And now you divide both sides by the surface area of this copper plate, and it would just be 2A, and I just put the 2 before the epsilon. The number should go first since it looks better in the opinion. But yeah, numbers before letters. So yeah. So anyways, this turns the equation. So anyways, now we have to plug in the surface area, the area of a circle for A, and that's pi r squared, and and it turns this equation into E equals the enclosed charge over 2 pi r squared times epsilon naught. Now we plug in the numbers. Q is negative 2.5 times 10 to the negative 9, divided by 2 pi times the radius, which is 6.5 centimeters or 0.065 meters squared, times epsilon naught, which is just 8.85 times 10 to the negative 12. And you should get an answer similar to 1.1 times 10 to the fourth newtons per coulombs. So that's the electric field strength on the blue dot of this copper plate. So part B asks which is the direction of the electric field on that blue dot that I just showed you. So it's going to go towards the plate since the plate is negatively charged. And that's your answer for part B. Part C, what is the strength of the electric field at the plate's center of mass? So as you can see, this yellow dot is in the center of mass of this plate. So it's in between, but it's in between both electric fields on this red and blue dot that are equidistant to this plate. So basically, this yellow dot is in electrostatic equilibrium. So basically, the electric field strength is zero newtons per coulomb. So that's your answer for part C. So yeah, part D asks for the same thing for part A, except it's below the copper plate. It's still the same distance from the copper plate. It's just in a different direction from the copper plate. So your answer should also be 1.1 times 10 to the fourth power newtons per coulomb. And then no matter what, the negative will always the electric field always guides to wherever it's negative, so it goes from positive to negative. So parity is asking the same thing as part B, except it's concerning the red dot I showed you. So it's gonna go towards the plate, and that's your answer for part E. So anyways, that's all the video. Here's the work just in case. But anyways, see y'all in the next physics explainer.